Okay, in this video we're going to look at finding the derivatives of the composition of functions, where let's say we have a function defined as f of g of x, and we want to take the derivative of that with respect to x. Well, to do this, we're going to use what we call the chain rule, where you start by first finding the derivative of the outer function, so f prime, and leave the inner function alone. So I'm going to leave g of x alone. So I'm going to differentiate the outer function, leave the inside alone, and then we're going to multiply that by the derivative of the inner function itself. And there's a number of ways to write that derivative. And all of the different ways are right here in this slide. Some are useful when applying some formulas later down the road. However, in this video, I'm going to primarily work with the function composition notation. Now, one of the first things that we need to do is to be able to identify whether or not we would actually need the chain rule when finding some derivatives. And we have some examples here. And the way you can tell whether or not you're going to use the chain rule is, do you see composition of functions or not? For instance, let's look here at the first column. I have x squared plus 1. I don't see composition of functions. I see x being squared, and I see minus 1. However, the one beneath it, we have composition of functions because we have the square root function, and inside of it is x squared minus 1. So you see the difference. Now, right here in the next column, if I have just sine of x, there is no composition because x is inside of sine. However, if I made that x 5x, I now have composition where the outer function is sine and the inner function is 5 times x. So that way you can kind of see what it is we're looking for. So now let's go through the process of finding the derivatives of some of these composition of functions. And you start by looking at this in terms of inner functions and outer functions. And I'm going to rewrite f, and I'll color code a little bit. So the outer function is cosine, and the inner function here would be 2x squared. And to find our derivative of f, we would apply the chain rule, which says take the derivative of the outer function. Derivative of cosine would be negative sine. Leave the inside alone, so it'd still be 2x squared. And then multiply that by the derivative of the inside, which would be 4 times x. And so our derivative here, f prime of x, would be equal to negative 4x times sine of 2x squared. All right, next one here. So we have g of x, and that is, g of x is the square root of 3x minus 2. And so I'm going to color coordinate this so you see what the outer function is and what the inner function is. Well, the outer function in this case is the square root function, and the inner function here is 3x minus 2. And so to find the derivative of g, we're going to first take the derivative of the outer function. Now, for some, it is helpful to rewrite the square root as a rational exponent. And so we do the derivative of the outside. So for this case, I do power rule. So it'd be 1/2 times, leave the inside alone, decrease the exponent by 1. So I still have 3x minus 2 inside of there. So we differentiated the square root function. Now multiply that by the derivative of the inside, which would just be 3. And then we would clean this up, and we have the derivative of g would be equal to 3 over 2 times the square root of 3x minus 2. Now let's go to another one. Here, so h is defined as sine squared of x. I want to find the derivative. Well, identify the outer function and the inner function. H of x could be rewritten. The outer function is the squaring function, and the inner function is sine of x. And so we would go through the process of finding our derivative. So you start by doing the derivative of the very outside, which would be power rule. So the derivative of the outer function would be 2 times, bring the exponent out front, decrease the exponent by 1. All right, so I still leave the inside alone. Now we multiply by the derivative of the inside. And the derivative of the inside is cosine of x. And so our derivative can be simplified in this case to being 2 times sine of x times cosine of x. All right, next one here. And you might be asking yourself, well, how is this the chain rule? I see the quotient of two functions, 1 divided by 4x plus 1. Now, in an earlier video or in class, you hear me say, I try to avoid the quotient rule as much as possible because I think that it's bulky and it's not very user-friendly. And here's a prime example of where rewriting this problem can actually make it much easier to work with. So if I rewrite this as 4x plus 1 to the negative 1 power, that's the same thing as 1 over 4x plus 1. Well, now you look at this and you can see the composition of functions where I have the power function, x to the negative 1 power, and the inner function of 4x plus 1. Now we're ready to take the derivative. So the derivative of s with respect to t, start with the derivative of the outside. So power rule, so power down, decrease the exponent by 1. And then we're going to leave the inside alone, so leave it as 4x plus 1. I didn't change anything there, I just did the derivative of the outer function. Now multiply that by the derivative of the inside. Well, the derivative of 4x plus 1 is just 4. And we can clean this up and say the derivative of s with respect to t would be negative 4 over 4x plus 1 squared. So we found the derivative using the power rule with the chain rule as opposed to using quotient rule. Okay, another one here, they start to get a little bit more complex. So this here, I actually have the composition of 3 different functions. So f of x is equal to, the very outer function here is the cubing function. And inside of it, we have the sine function. So I have sine of. Inside of here, I have the square root function, which I'm going to go ahead and write as with a rational exponent. And then the very, very inside, I have 4x plus 1. So we actually have 4 different functions in one here. And so we want to find the derivative of this composition of functions. And you have to proceed here very carefully. So I want to find the derivative of f. So you start from the very outside of the shell and then work your way down. So I do the derivative of the outer first. So it'll be 3 times everything on the inside, decrease the exponent by 1. The inside stays the same, so it'd be sine of, or sine cubed of the square root of 4x plus 1. All right, so I did the derivative of the outer. Now we go times by the derivative of the inside, which the derivative of the inside, I would first start with sine. Derivative of sine is cosine. And I'm applying the chain rule again, so it would be cosine of all of the stuff inside of it. So it would be cosine of the square root of 4x plus 1 times the derivative of the inside, which now we're on the square root part. So it would be times 1/2 times 4x plus 1 to the negative 1/2 times the derivative of the very, very inside, which would just be 4. So this turned into a pretty expanded chain rule process. And then you would just clean that up, but for the sake of this video, I'm just going to leave it just like that. Okay, let's do one more of these big things. All right, so I have the composition. I have multiple compositional functions happening here. And what I'm going to do right out of the gate here, because I want to find the derivatives, I'm going to rewrite f so that way it's a little bit more user-friendly. So f of x is going to equal 3 times, and I'm going to bring the square root up, and I'm going to start color coordinating this. So that'd be all the inside part raised to the negative 1/2 power. And inside of here we would have tangent of, and inside a tangent would be the very inner part of the composition, which would be 4x squared plus 1. Now we're ready to start the process of finding the derivative. So you start by taking the derivative of the very, very outside. So I have 3 times. The very outside outer function is the power function being with the exponent of negative 1/2. So multiply the exponent out front, decrease the exponent by 1, so it'd be to the negative 3 over 2. I'm going to leave the inside exactly the way it was. So tangent of 4x squared plus 1. So we did the derivative of the outer times, now start working for the derivative of the inside. Well, the derivative of the inside, I first get the tangent. So I have to find the derivative of tangent, which is going to be secant squared. So it'll be times secant squared of the inside times the derivative of what's inside of it, which would be 8x.